In this lecture, we will learn about different types of arrays in Python. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. Arrays are used to store multiple values in a single variable. There are different types of array based on how data is arranged inside them. The most common types are one-dimensional, which is 1D arrays, two-dimensional 2D arrays, and multi-dimensional arrays. Each type has its own use depending on the problem we want to solve. A one-dimensional 1D array is the simplest type of arrays. It stores data in a single row or a single line, just like a list of items written in a notebook. You are already familiar with 1D arrays because we use them in our introductory lecture. They are useful when we need to keep track of simple lists, like a list of employee names, product prices, or customer IDs. Since 1D array has a one row, we can easily access any value by referring to its position, which is index. All right, a two-dimensional 2D array stores data in rows and columns, similar to a table or a spreadsheet. It is useful when we need to organize information in a grid-like format, such as storing sales records, student marks, or warehouse inventories. A multi-dimensional array goes beyond two dimensions and is used when data needs to be stored in a more complex structure. These arrays are like 3D cubes or layers of spreadsheets stacked on top of each other. They are used in situations where multiple factors affect the data. All right, let's take Nike as an example. Suppose we are working for Nike, one of the biggest sportswear companies in the world, actually. Nike needs to track the sales of different shoes models across its stores in multiple countries. A one-day array can be used to store the sales numbers for one particular shoe model across different stores. If Nike wants to compare sales of multiple shoes model in different stores, a 2D array can be used where rows represents different stores and columns represent different shoe models. All right, if Nike wants to go even further and analyze sales trends over several months, a multi-dimensional array is needed, where one extra dimension represents the time period. Before we go into 2D and multi-D syntax, we first want to mention that in Python, we typically use lists for 2D and multi-D data structures because Python does not have a built-in array type like other languages such as C or Java. But if you need true array functionality with better performance, especially for large data sets, you should use NumPy arrays, which is an advanced concept. Don't worry, we'll discuss NumPy arrays in our upcoming advanced sections. In Python, the syntax for a 2D array involves creating a list of lists where each inner list represents a row and the values inside represent columns. We can access a specific value by using two index numbers, the first for the row and the second for the column. And the multi-dimensional array follows the same concept by extend beyond two dimensions. It is creating using nesting lists within list multiple times, representing layers of data. Each additional dimension adds another index number needed to access a specific value. Let's get back into the Nike's example again and practically perform it. First, we need to store the sales of different shoe models in multiple stores. So we create a two-dimensional array. In this array, each row represents a different store, and each column represents the sales of a specific shoe model. The first row stores the sales of three shoe models in store 1. The second row represents store 2, and the third row contains the sales data of store 3. Each number inside the array shows how many units of a particular model were sold in that store. Now we want to analyze sales trends over time, so we create three-dimensional array. This allows us to track sales across different methods. In this array, the first dimension represents the month, the second dimension represents the store, and the third represents the shoe model. The first section of this array stores sales data for January, where each row follows the same structure as our two-dimensional array. The second section stores sales data from February, following the same pattern. By structuring data this way, we can easily compare sales between months. Next, we need to find a specific sales figures. For this, we check the sales of model A in store 2. Since our two-dimensional array organizes data by store and model, we look at the second row, each represents store 2, and select the first column, which represents model A. This gives us the sales number for model A in store 2. After that, we want to find out how well model B performed in store 3 during February. Since February is the second month in our sales trend array, we go to the second section. Then we find the third row, which represents store 3, and select the second column, which holds sales for model B. This helps us see how many units of model B were sold in store 3 during February. Finally, we display these results. First, we print the sales of model A in store 2, showing the number of units sold. Then we print the sales of model B in store 3 during February, helping us analyze sales trends over time. All right, let's run this program. Here you can see the output. So by organizing data in this way, we can easily access and compare sales information across different stores and months. This methods allow companies to track performance efficiently and make informed business decisions. And I have incorporated the example of Nike store because so you could actually picture how Nike would incorporate this type of programming code into their software to get that result. Maybe one day you will be working for a bigger corporation who will be dealing with the inventory and would ask you to perform some type of data similar to this. Then please make sure this lecture, types of array, will come back to your mind so you could write the code efficiently. Beautiful. I'll see you in the next lecture. And let's keep learning together.